Good morning, class.
चलो मार्क्स अपडेट अब हो जाएंगे क्या?
So, so today we will discuss about the Bluetooth technology, which we could not cover in the previous lecture. I'm just sharing just wait. I'm sharing. ये सभी को दिख रहा है? अभी शेयर किया मैंने. Is it visible to all of you? अभी शेयर किया है.
यस सर.
Okay, okay. So in this context, exactly the IEEE 2.11, that is the Wi-Fi LAN system, which is covered in the previous lecture, in which we have discussed. I'm just going to just give you the brief idea of the previous lecture which we have covered. So in this previous lecture, for IEEE 802.11, we have covered the primarily we have discussed about what is the IEEE 802.1 Wi-Fi based system. Then we have covered the architecture, which includes the ad hoc based network and infrastructure based network. And I have told you that in ad hoc network have no access point, and while in case of infrastructure based system, basically an access point is required. You can see from the diagram, the access point is the point where the which involves in the communication between BSS to BSS. If we require a communication from basic service set from one range of one communication area to another communication area of BSS, then we require the access point. So if we talk about the infrastructure BSS, access point is required, while in case of ad hoc based service network, there is no access point is required. Clear? Now this is the diagram for extended services system, where you can see we have three different zones having BSS stations clear along with the access point, and they all are connected with the distributed system. That is the centralized system where all the access points are connected and they in particular domain. Yeah, and there is a server or gateway through which the distributed system can get communicated via packet or frame. Clear? Now, if we talk about the max sub layer, which is a very important part of this 2.11 system, clear? This exactly covers exactly covers two type of distribution system. First one is point coordination function, and another is the TCF function. That is the distributed coordination function. ठीक है. फिर हम लोगों ने TCF डिस्कस किया था. TCF के अंदर हमने बताया था आपको ये एग्जैक्टली CSMS CA प्रोटोकॉल को यूज करता है. This is a very important max-up layer in IEEE standard, which is having the frame exchange timeline. This is the frame exchange timeline exactly for the DCF based system here, which uses the CSMS CA and NAV system. Clear? Now the upper one is the MAC layer in IEEE 802.11 standard, which consists of LLC sublayer and MAC sublayer. MAC sublayer again is divided into PCF and DCF. Clear? After that, we have discussed the data link layer and physical layer, which data link layer is containing the MAC sublayer and LLC sublayer, and the physical layer containing exactly the IEEE 802.11 frequency hopping space spectrum and 802.11 DSS direct sequence spread spectrum. Yeah. Now, how the packets get transmitted here, how the frame transmission takes place, we have discussed in this particular scheme. So you can see we have a source station A, destination is station B, and then other stations is having C and D. Clear? So if the packet or frame from source station A is getting transmitted to the destination side, so station A basically wait for a particular time instant that is called DIFS, that is distributed interframe space. It is the time which is exactly called the waiting time for the source station A, on which it sends the media, is it ideal or not, and accordingly it take the decision for sending the packet or data into the system. Clear? So now, so it wait for the DIFS time, this space time, and then send the RTS request to the destination. That is what request to send. This RTS request, when received by the destination address, it again waits for an instance space time, that is SIFS, called short interframe space. It waits for this particular space interval and then send the CTS, that is clear to send request to again source station A. Clear? Then source station A again, after getting the CTS request that is clear to send by the destination, it again wait for the SIFS time and then send the data to the destination address, and then it get the acknowledgement, and then the communication is accomplished. Means the path is like this, 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 and this. This is the type of communication. And if you see in between C and D, there is a NAV. NAV is one network allocation vector, which is a type of vector times those who are not exactly active between the system and ever another station is sending their data into the system. So they are just having the wait time interval, that is called NAV. After this wait time interval, they can sense again they can sense the channel. The channel is idle. Then they can send the packet to the system. Otherwise, they will again wait for the NAV duration. Clear?
Yes, sir.
Electricity there that station, so station, so it may reach to the SG also. In that case, if it finds the request which is not originally generated for this, it is someone is accessing the channel, or it can also think that the station D is also involved in the accessing, wherever this involved नहीं है तब भी उसको लगेगा कि स्टेशन डी हमारा इन्वॉल्व है, क्योंकि उसे नहीं पता स्टेशन डी के बारे में, उसको नहीं पता स्टेशन ए के बारे में और स्टेशन बी के बारे में, ठीक है ना, तो वो इंडिपेंडेंट है, वो तो उसको नहीं समझ में आएगा कि कौन सा स्टेशन ट्रांसमिशन में पार्टिसिपेट कर रहा है, तो इसलिए वो डेटा को एक्सेस नहीं करेगा उस टाइम पे, ठीक है। ये भी एक बहुत बड़ी प्रॉब्लम है इस सिस्टम में। तो उससे क्या होता है, हमारा चैनल एलोकेशन जो होता है वो वेस्ट हो जाता है। Problems which is getting into the system, such as a collision during handshaking. Is during handshaking process, handshaking is there, so handshaking process is done, but in that case also the collision happens. So this is the problem in between that. Now the what, someone doesn't know about the station properly. Means suppose as I have already told you, the station C doesn't know about the station D. So if the RTS request is generated for a start not to C, so it is a type of hidden station problem. Here is using two type coordination. The point distributed coordination is already done. So now the next one is the point coordination function. In this particular coordination function, it exactly is a type of polling access method, using a polling access method which we have already discussed in the previous sections. The AP perform, the access point perform the polling for a station that are capable of being polled, and then the stations are polled one after another and sending any data they have to the access point. Clear? So due to the priority, it gives the priority to PCF or DCF. DCF के ऊपर PCF को priority दिया जाता है क्योंकि हमारा another interframe space PIFS has been defined. Clear? Now this is the another scheme you can see. During the reception interval, the point controller can send a poll frame. Receiver data send an acknowledgement. Receive and जो sender है वो poll frame generate करता है और receiver उसको acknowledge करता है. Clear? Clear? This is the this is the reception interval. This is the contention duration. We talk about the wait frame. This is very important field standard, data link layer and data link layer. Clear? In this particular frame format, we are having and another is having the fields information. So the upper layer is this and lower layer is this. The upper layer having the FCD address 1, address 2, address 3, SC address 4, frame body, and then FCS. Clear? So these are exactly the upper layer fields that is of having the byte information. You are having add 4 addresses in this particular scheme, and the lower one is having the protocol version type subtype 2ds from ds more flag and then read try power management more data web and reserved. Clear? So it is having they all are exactly the subfield is the in the category of this PC portion. Clear? The first one is if you see first field is version that is the accessing that point ds is the defined source and from ds means वहां से data आ रहा है. ठीक है? And then after that more fragmentation field is there, then power management, then more data, then wired equivalent privacy network, then reserved system. So all are given with their particular details, which we have already discussed in the which we have already discussed in the business section application. Now we move to the next one. Am I properly audible to all of you?
Yes, sir, you are audible.
So now continue further. Now, if I talk about the frame type is another important type. Having it is having a wireless LAN defined by IEEE 802.11 management frame, control frame, and data frame. The management frame are used for the initial communication between the nearest station and accessing the channel and acknowledgement frame. सबका अपना अलग अलग रोल है. ठीक है, you can see 1011 use 100. This is management. Clear? We have discussed these are the addressing mechanism this particular domain in this particular system. This is a very important question. Why we use 4 addresses here? Is decided by the two DS and from DS bits. Clear? So there are 4 components that which address is specifically designed for which purpose. So if both the DS, 2DS and from DS are 00, then the address 1 will be the destination address, address 2 will be the source address 3 will be the BSS ID, address 4 is not available. If both addresses are 01, then destination address will be the address 1 and the source address 2 will be as a sending access point, address 3 will be the source address 4 is not available. So there are exactly 4 combination of the addresses. So this table is very important if someone asks about the IEEE 802.1 frame structure having 4 addresses. Clear? So these all cases are discussed later, given on the bottom side. And the above one is a diagram for these addresses. You can one in the first case you can see there is no use of distribution. The two DS and from DS both are 00, so you can say that one from DS is in the second case you can see the from DS is one, so the address one will be the destination, address two will be the sending AP. So you can see this is another diagram of this. This is for case 2, this is for case 3, and this is for case 4. So all 4 type of addresses or 4 type of cases means 00011011 according to the 2DS and from DS. All 4 cases having 4 different diagrams. Clear? For the packet transmission. So I think it is clear to all of you. So अगर addresses के बारे में structure में different cases. Next that if A and B communicate to RTS request is again will access the data. But if suppose RTS request is sending to this C point also, so it will send the data towards this side or this side where so it is but it is not specifically know about which type of station is free to access the data. So this is a type of exposed station problem. So in this particular scheme the band allocation get lost. So जो भी इसका ये वाला पोर्शन है यहाँ डेटा कम्युनिकेट नहीं कर पाएगा क्योंकि इसको लगेगा स्टेशन बिजी है, बल्कि ऐसा नहीं है, तो उस कंडीशन में ये कम्युनिकेशन नहीं कर पाएगा. Clear? Now, these are some IEEE standards related to Wi-Fi system 802.11, which is having technique using FSSS, DSSS, clear, with the modulation as well as bit rate, both are given. Now 8021G, 802.11A, basically ये जो हमारे पास है ये important है. तो 11A is used for OFDM, 11B is used for DSSS, 11G is used for and 11N is used for again OFDM. आपको याद रखना बहुत जरूरी है क्योंकि बहुत इंपॉर्टेंट टेबल है ये. इससे आपको अगर आपसे 802.11 स्टैंडर्ड मॉड्यूलेशन रेट आपसे पूछे जाते हैं पेपर में, आपके ट्यूट में भी दिया है. ये देखिए 80 ऐसे ये ऊपर 802.11 सॉरी DSSS ये वाला भी गिवन है, फिर FHSS है. इस तरह ये सबके डायग्राम है. दिस इज फॉर FHSS, दिस इज फॉर DSS. PN you can see in the first diagram the PN sequence, yeah, pseudo random sequence is generated. This synthesizer will generate the multiple frequency to the modulator, which is a exactly level 2 or level 4 FSK scheme को use करता है and generates a 1 megahertz analog signal. Clear? So frequency synthesizer exactly used to convert the low frequency signal into the high frequency signal. देख सकते हैं DSSS का डायग्राम बना हुआ है जिसमें BPSK और QPSK स्कीम यूज हो रही है using hybrid chip H chip बार्कर सीक्वेंस. क्लियर? नहीं, ये आपको ध्यान रखना होगा IEEE 802.11B and A along with the N. तो ये आपके एग्जाम में भी पूछे जाते हैं क्वेश्चन. हेलो, वॉइस, हेलो, वॉइस इज क्लियर और नॉट? Stress system in clear the network. It is a type of personal area network where you can communicate for the short distance from one gadget to another gadget. Clear? It is basically projected by the Ericsson company in the starting. And now that we talk about the event, and IEEE 802.16 is the WiMAX system. So if we talk about the architecture of this, the architecture includes a piconet and scatternet system for this particular Bluetooth system. So piconet means होता है कि आपका एक small geographical area के अंदर आपका communication हो रहा है. ठीक है, एक small area में अगर आप communication करें, it is called a piconet network. It has stations होंगे, maximum 8 हो सकते हैं. 8 में से भी एक हमारा जो है वो centralized station होता है. Out of 8 station and another other substation or the secondary station. Now, if you talk about so in this particular domain, if someone belongs beyond this 8 stations, yeah, someone beyond the 7 stations want to communicate, so it will be acting as a still network and still station, and it can communicate only if it involves in the 7 piconet system. Yeah? And till then it will wait for the time duration, but system of the piconet. This particular diagram is a type of paper, and there are not more than one system. One will be so the primary will get access to the secondary system. Now the another architecture network is scatternet. Scatternet में क्या होता है कि हमारे पास एक पिकोनेट से एक तरह से दूसरे पिकोनेट में कम्युनिकेशन हो जाता है. दिस इज a type of piconet to piconet communication. ठीक है, तो इसमें क्या है, जैसे मान लीजिए एक पिकोनेट में हमारे पास एक प्राइमरी है, बाकी 7 सेकेंडरी है. तो जो ये 7 सेकेंडरी में से अगर कोई एक सेकेंडरी दूसरे पिकोनेट में जाके कम्युनिकेशन करता है, तो वो जो सेकेंडरी जो हमारा दूसरे नेटवर्क में जाएगा वो वहाँ पे एज ए प्राइमरी काम करेगा. दिस विल वर्क एज ए प्राइमरी which is working as a secondary in the first piconet. will work as a primary in the second piconet. Okay, so this is the second piconet, and rest of what scatter net network. Here, on a scatter net network, from one and this station is this devices. You all know this is a short range radio transmitter. The current data rate is exactly 1 Mbps with a 2.4 gigahertz bandwidth. Okay, so we have current that is 2.11 B wireless getting interference. So Bluetooth layers defined. पहले हम लोग सबसे पहले डिस्कस करेंगे ब्लूटूथ लेयर. It is known as logical link control and adaptation LLC sub layer in the local area network. This is the baseband profile, then application. This is the audio and control system. Clear? So now this is the data frame format of L2 cap, which is having exactly 3 fields of this L2 cap system. L2 का मतलब ये है कि आपने हमने इसका आपको फुल फॉर्म अभी बताया था. L2 का मतलब है लॉजिकल लिंक. तो there are two terminal link, control application protocol, control and application adaptation protocol. So this is L2 cap. That is logical link, control and adaptation protocol. So my voice is clear to all of you.
Yes.
L2 कैप का ब्लूटूथ सिस्टम है. तो फ्रेम आपका देखिए 2 बाइट का लेंथ है, 2 बाइट का चैनल आईडी है, 35 बाइट्स का डेटा एंड कंट्रोल फील्ड है. ठीक है, इसका फ्रेम फॉर्मेटिंग L2 कैप का क्वेश्चंस आ सकते हैं. तो देन कैन टू मल्टीप्लेक्सिंग, ये मल्टीप्लेक्सिंग भी परफॉर्म कर सकता है. एट द सेंटर साइड इट एक्सेप्ट डेटा फ्रॉम वन ऑफ द अपर लेयर प्रोटोकॉल फ्रेम्स देन एंड डिलीवर देम टू द बेस बैंड लेयर. जैसे मल्टीप्लेक्सिंग का बेसिक फंक्शन क्या होता है कि डेटा को कलेक्ट करना और उसको सिंगल चैनल पे ट्रांसमिट कर देना. तो वही चीज है कि इसको एक साथ डेटा कलेक्ट बैंड लेयर. At the receiver side, it accepts a frame from the baseband layer, extract the data and delivers them to the appropriate protocol layer. Okay. Now, if we talk about the segmentation and reassembly, so it has the maximum size of the payload field, that is 2774 bits. The L2 cap divides these large packets into segments and add extra information to define the location of the segment. In the extra segment में break कर देता है, कई बार उसको भी हो जाता है. तो उसको क्या करता है, छोटे को हम कुछ पर्टिकुलर टास्क असाइन कर देते हैं, एक एक्स्ट्रा इन्फॉर्मेशन उसके साथ ऐड कर देते हैं, कुछ और आ जाएगा. ठीक है, तो इस तरीके से जिससे हमको क्या करना होता है कि इसको सोर्स और डेस्टिनेशन दोनों डिवाइड करने के बाद. नाउ द नेक्स्ट वन टू डिफाइन ए क्वालिटी ऑफ सर्विस लेवल. Quality of service level is called best. Now, if you talk about the group management, this is the another functionality of L2 addressing. Now, then baseband layer. Now, it is using a basically. This is very important. So, agent duplex basically the primary stations whenever and if secondary will send the data, then primary will not send at a time. So, this is a half duplex communication. So the primary senders are allocated the time slots, odd time slots. You can see these are the odd time slots. तो जब primary भेजेगा तो वो even memory को. तो इस तरीके से communication चलता है. कहते हैं this is also known as single transmission. And if we talk about the multiple transmission, you can see secondary होते हैं. ठीक है,